Right, well, first off, welcome back. I'm out in the garage. I've heated it up, although we're still out only on 10 degrees. But I'm going to try and carry on with some jobs on this spindle sleeve. The end caps will need doing, and I think this is for the spring. There's a tension spring. It fits in there and it causes tension on the AC bearings when the spindle's inside. So that's got to have 6 holes drilled in it. So yes, again, thank you for everyone that asked how I was doing. Physically, not too bad. We'll just see what all the testing does in a couple of weeks' time. But that's by the by. So first off, I'm going to go and get the drawings because I can't for the life of me remember what needs doing, and we'll do a bit more explaining then. Right, we're on the destruction manuals. Now, what I've got to do with this is going to go in the jaws, clocked up to, it's got to be spot on. And then these are going to be when I can start the thread. There we go. And I want to do these in the thread to try and get them as concentric as possible. And I'm hoping that once they come out and go back in, they'll virtually stay that way. But Sod's Law says something will change. But I'm going to face it up, and then if you notice down here in this picture in the destruction manual, we have a groove. Yes, I'm trying to use Lavelle mic things, so we're going to see how it all goes. It's got a groove in the face. In the face there. These are all for these labyrinth, where the labyrinth seals fit. Now, that's quite deep, that, and you've noticed on the picture here, he hasn't made a tool. That's been bought. Now, a long time ago, I had this kit. I turned it down from when I had my Myford, and obviously these different attachments for doing bits in your bore that way. These bits for internal screw cutting. This manufacturer that we shan't mention, but the name's there. Whether you can still get these things, I don't know. But anyway, there are other manufacturers, where have they gone, that do tips, and lo and behold, these fit in the end of them as well. Well, they seem to. So I've got a groove in the end, and that groove is, oh, I don't know, it's about 2.5 mil or something. Let me go and check. Right, now I've just checked. On the drawing, they've actually got that 1.65 wide and about 5 deep, and quite frankly, I think that'd be a mare to do. It would be at that depth. Yep, 4.9 according to the drawing. So I'm going to do a little bit of altering. I've got a tip that's 2, so it's going to be 2. Now the thing is, I'm going to attempt to cut it, not one continuous cut obviously, but going in steps. This diameter on the inside there, I'm going to keep as what it states on the drawing, but it will be wider. What that will mean is when I get to do the spindle, the diameter of the spindle up there will correspond to that groove. Obviously, they're slightly smaller So I've got to try and put something in there as well. And the bigger, slightly better, probably. Now, once I've done that, I've got to then put the grooves inside. It's like on this PC, you can see the grooves inside. They look like a thread, but they're not. You can see the groove in the face and the grooves in the side. This is to stop rubbish getting in and out. Apparently this works. So once that's been done, you can see that's held in situ in the sleeve as well. So once that groove's been done there, and we haven't snapped that, we'll then start on the inside. And the drawing states it wants 4 grooves, the distance you've got, 0.8. Now, these tips I've been able to get hold of, and I've got some off Best Flea Bay and everywhere else. This one's 0.75. I can't see that making any difference whatsoever in the face. I think you might be able to see, you might not. Saves me trying to make something. If someone's got something off the shelf, goes in that way, and obviously it can go in the bore and do me grooves. That is going to be the plan. My lathe hasn't been running for ages. You may be able to hear it running in the background. I am giving it ample time to warm up, get the oil round. Say things are critical on this, or these sizes, the size you've got of that diameter and the size of the inside of the groove, that diameter to there, your spindle is going to have, it's going to be like that. But it's got to miss. It's got to have, if it's good and concentric, you're talking 1/1000 clearance either side. So we're going to see how we get along with that for the time being. I'll turn my heater up, get a bit more heat in here, and we'll see how we get on. Morning everybody. Right, it's been a while, and I said I was going to do some stuff, and I was getting better, and then I got the dreaded lurgy, which kicked me on my arse for a fortnight and stopped me going for treatment and all sorts of other stuff. But anyway, the bad news is I'm probably back on work next week, so I must be better. Anyway, matters at hand. Right, now this is the spindle sleeve. It's not fully machined out except for one little drill hole, which will be on the milling machine. What I'm doing next is these are the end caps, which need 1 facing up, 2 boring out, and then the labyrinth seal put inside. So first off, the way when you look at it in the book, they're done in situ on here, which is the best way to do them, I suppose. Then they should be running concentric with everything else, as long as everything adds up, which is always the main thing. So anyway, while I've been off and a bit ill, my DTI clock, whatever you want to call it, is a bit on the old side. But anyway, I purchased myself a metric one here that is very fine. It is, what is it? 1/10 of microns, 0.001 of a millimetre. Convert that to imperial if you want to. It's about 0.0001 tenths of 1,000. Anyway, it's close enough. So anyway, that's on there, and I don't know if you can read it, but it's been tapped true. We can move the point around. It's only got a milli travel, this clock, like I say, because it's a fine one. It takes a little bit when it settles itself down, but we are moving there about 0.002 of a millimetre, which is probably in the region of a tenth-ish of 1,000, with a couple of tenths, whatever the heck. which I think is good enough for purpose. Right, let's move that away. Now, what I'm going to do first is just touch on the end of there with my tool, and that will be 0, because this has a thickness on there, and when this tightens up, I've already tried it, and I will just show you what I mean. I tighten it up and nip it with a little spanner, and then check to make sure there's no gap there, which there wasn't. And because I've got a 0 there, I'm going to face these off then to size, and I'm going to try and do them all. Hopefully they should all be running, and the other end they should be running true. I might even mark one up for this end, knock it round. I think I will do actually, and then I'll like custom make them. But I've got to face this off, then bore it and put the labyrinth seals in, and there's an O-ring groove. Well, it's not an O-ring groove, but it's a deep groove in that face, which will be interesting. Going to do one complete, obviously all in situ, and then I will probably mark it up and do the other one and keep them as a matching pair. It'd be interesting once I've turned it round and clocked it up to put a machined one in and clock the bore. Anyway, that's the plan. We'll see how we go. Right, now the drawings give us a size and thickness on these things, and it's 2.8 mil, working off millimeters. And it's an open size, but obviously we don't want to go any thinner, because when you put the groove in there and everything else gets altered. So, like I say, I've touched off the back of here. I cannot get a thou and a bit feeler through. It will not go in there. So we're going to touch on and take this down to just over 2.8, 2.805, and then give it a quick polish, and then that's the face all flicked up. Right, so that's that face done. I'll get myself a boring bar set up, small enough but good enough to go in there, and we'll look next at the size it needs boring at. Right, swapped out for this boring bar. Now the finished size is 17.53 in metric. 690 thou, I think. Hang on. Yep, 690. But we're working in metric. So first off, get an idea of where I've drilled it. So we're on 17 mil there. So I've got half a mil, left half a mil. I will try and aim for 17.5. The shaft that's going through is 17.4, so there's only 4 thou clearance, or 2 thou aside depending on which way you want to look at it, which is big at one point and not big at the other, I suppose. The other side of this, there's a pulley fits on these. These are all the same size, but like I say, I'm going to try and get them done the same, and then as well as the shaft, the pulley's going to need manufacturing, but we'll get around to that in a bit. So I shall try 0.2 first off, and just give it a measure. Right, so that's the DRO set back to 17 mil, and I'm going to try 0.2. Slow that feed down a little bit. And try a little bit of oil on there as well. No coolant, just a slight little bit of oil, help it along. It looks not a bad finish, it feels not a bad. Let's have a measure. That one's a bit big. Next size down. Make sure the mic's reading right. Yep, got 0 on that. Because obviously some of this stuff hasn't been out for a while. Well, I've not been too bad, too good. I have took time out and ran the spindle up because this machine hasn't been run for a while. Like I say, I did oil it up as much as what I could, and I have run the spindle at a few hundred RPM for 10 minutes or so. Let things get warmed up and see how it all feels. Right. Right. I'm saying I've got hold of my 0 to 25. I've actually gone and got hold of my 0 to 1. Right. Let me just go and get the right micrometer. There's no point in swapping over metric imperial, imperial metric. And I could do, but I'm here. Right, well, I don't know what happened with my camera then. It kind of bombed out. But we'll go back to where I was. I am now first cut on this bore. I touched on at what I thought was 17. Took off 0.2, and I've got 15, 16, 17.22 there. So I'm going to enter that into my DRO. Like I say, and I've got a size, we're looking for 17.5. So I'm going to go straight to size to 17.5. I've just took 0.2 off, so fingers crossed, it should be all right. Right, let's give that a measure. On the DRO, I was actually heading for 17.48. And let's give it a light polish. we've got approximately, well, rough, no, 17.48. Now I'm going to double check it with a little bore mic. I keep forgetting I've got these. I think they're all right for shallow, but obviously some proper Bauer mics. Well, I think we'd all like some of them, but even they have their limitations in a sense. Right, now then, getting the touch on there, obviously reading back. So you've got 20, 19, 18, 17 and a half. Now I've got 17.48 on that as well. So I'm going to leave it at that. I can always make my bit to fit. One end, I don't know which end this is. I'll know once I've marked it up. One end's got the pulley on, and one end has the end of the shaft on. And I'll get round, like I say, I'll custom make it. You're talking a couple of thousand, but owing to the fact that these things are custom made, everything's going to be custom made. So next thing to do, I'm just going to deburr it and get set up with the tool. I'm going to do the face next and see how we get on. Right, we're going to try again now because the battery keeps going because it's that bally cold in here. Well, say it's cold, it's 4 degrees. Right, now this is a face grooving tool specifically made for face grooving with an old tool holder that I've had for ages, and this purchased off Best Fleabay. Now it asks for a groove of 1.65 wide. I can't get a tip that faces in the groove 1.65 wide, and I am not about to start grinding this. This is too wide. So I'm going to alter the dimensions on the spindle and the pulley that's on the other side to suit. There is enough material to do so. It will not in any way, as long as I get into the diameter, the bottom diameter, there is enough material on the outside of the groove, and it shouldn't in any way kind of cause any detriment to anything. So I have touched on the side of here, clocked it up, I know it's running true, took the diameter of that, put it on that tool on the inner face, touched on there, so that's my 0. I'm leaving 0.2 to clean up the bottom of the groove because this is too wide. This is going to be interesting, I suppose. I'm going to cut it fairly slow and probably with quite a bit of coolant on to see how it goes. Let's have to find out. Right, I think low box. That's about 200 RPM, so we'll see what things go like. And I've got to go about 4.9 deep, so it's all going to be interesting. Right, so I'm going to take it easy. Got some coolant running. Like I said, I've got 4.9, and at the moment I'm about 0.2. Depends how it cuts. This is free cutting, so at the moment it's coming off all right, but we'll see. Anyone that's done face grooves knows it can be interesting. Depends on the flex you've got on your tool as well, and unfortunately this one has stuck out quite a way. Now, one thing I'm going to do now is just stop it and check this diameter. I mean, it's a bit late now, but might as well check it. Obviously, with a set of calipers, there's nothing else is going to go in there. That is 20.78, which is virtually what my DRO's got. I say I wanted 20.6 as a finish. That might do. We'll see what the finish looks like. We're still going. We're at, give me a minute, 4.1. I think it's cut slightly big on the OD, but we'll adjust for that. Right, that's me touched on at 4.8. And what I'm going to do now is turn my coolant off and just come in 0.1. It doesn't seem to be touching, so I might have a bit of flex. Now that's rubbing. That's cutting. And on my DRO that says 20.65. We wanted 20.6. That, according to my DRO, it's 4.9. Now, so all we can measure it with, really, are these. That's roughly 20 points there. It's 20.6. Oops. 20.662. So we'll see what we've cut on the outside now. See, I think it's cut a bit big. I've got 20 point, nearly 24.9. So what I'm going to do, I'm not going to wind back. I know that's on 20.6. I'm going to take the backlash out and go to 20.7. Well, we started off on 20.8. That's right. So I'm going to go to 20.8 and see if we cut. And we haven't. And wind back again and go 20.9. And that's cutting a bit further down. That's beginning to cut now. We might have a slight taper in there. But I don't think the outside, because of where the labyrinth is, it will make much difference. I've got 25. 25 for that. So if this is a 2 milli tip, but it's overcut ever so slightly, it's flexed or I've moved, one or the other, it should have been 25 to 21. And it's not, we've got 20.6. So we've overcut about 0.2 with it. Or it could have been me, I've knocked it off. Yep, definitely 25 there. Saying that, I am getting there now about 20.6566. 6.4. So call it 6.5, 20.65 to 25. You have 4.35, which means it's actually overcut 0.075, or that might have been with me cleaning it up. So it's gone pretty close to what it should have done, ish, he says. But I did clean them up a little bit. So what I'll do, the matching face that's going in there will have to match these plus a little bit of, I think it wants about 0.1, 3 to 4 thou clearance, probably 2 thou a side, hopefully, as long as you machine them properly. But that, at the moment, I'm going to leave. Right, now, I've done that bit. The beauty of these, it's all very well making tips and making a grinder that makes all these bits, but in the 21st century now, along with everything else, you can get inserts. And I've got this little insert here from a tool maker, and it's 0.75 across there. And the beauty of these things being indexable, it is kind of cheating a bit, but where there's a will, there's a way. We're making the tool for all sorts of other things, but anyway, you can take one tip out, put the other one in, and because they are generic, should all be same tool height, he said, hopefully. Now that's 0.75 wide. On the drawing, it asks for 0.8. It's a labyrinth seal. It's not going to make any difference. I'm going to be doing the same thing again. Touch on the end. Know the width of my tool. I think there's 4 slots got to go in there. I'm going to touch on, get the diameter, know how deep I'm going to go. And obviously you pitch over the distance of before the groove, and then the distance of the groove to come up against this back face. Then once you've done that, you pitch over again the distance of the space plus the distance of the tool, etc, etc, etc. So you pitch over probably twice what the width of that is, say, if that's the spacing you want, and that's how you'd work it out. And we want 4 of these, so if that is 0.75, and I know I've got enough material for argument's sake, I will touch on and pitch over 1.5 mil, go in, 1.5 mil, go in, etc. 4 times, and I should have 0.75 of a groove plus 0.75 of a width in between them, and I should get 4 of them in there. So we'll see. Right, we are going to be ready for liftoff. I'm going to pull the emergency stop out. So 1.5 on there. That's just touched. So 0 the DRO out. I'll soon know if I've gone too deep. Well, to be honest, here's a point. Right, I'll wind the DRO back. Get a brush. You could always check like this. You could actually wind out 1.6 there, and you might not be able to see it, but it does not break through. So we know that's going to be all right. So I go back to 1.5. Now here's a point. I've actually moved this. It's a good job I zeroed it out. Like a fool, I've caught it. So I can go back to 0 my DRO. This is where you should really lock. If you lock your table out. And then that's 0 there now with this DRO scale. So if I go in my 1.5, I can start all over again. There we go, and it went 0.8 without touching. Now, like I say, this, right, there's 1.6. So we'll have a little bit more oil. And I am going forward now a 1.5, so that's to 3 on this DRO scale. I've still got 0 on my big DRO. That's touching again at 0. That's a milli D. 1.6. Right, so that's 3. So I want to go 4.5. Listen for it touching. There's 0 again. That's out. Right, so this is the last one. So this is going to go to 6 deep. Like I say, it's free cutting, so it's cutting very easy. It'd be a lot more interesting if it was harder stuff. Right, now there's my 1.6. Now, do remember to come out. And come out far enough. And I'm going to wind it back with the top slide anyway. Right. And then I'm going to wind back with the carriage. Now, you can't see that, but I'm really pleased. 1, 2, 3. 4. Because it's thinner, I've got a little bit more material on the back. It doesn't matter. We've got the 4, let's see now, 1.5, 3, 4.5, 6. I'm making sure myself. See the 4 grooves. What I'll do, I'll swap the lens over on this in a minute and I'll show it you, because what I'm going to do now, I'm just going to deburr it all, and then I'm going to slightly mark. I'll felt tip it if I can. I don't want to start tapping, and I'll know which end I've done with this, and I'll show you what it looks like in a mo. Right, we're back on the bench. Note to self, when you're changing the lens on these cameras, try and strap them on the floor, and you end up cleaning them all. Right, so we've got the this macro-y lens fitted in, and if we get the light right, I think you can see there's the grooves. There are 4 of them. 1, 2, 3, yes, 4. You can see them in there, and obviously the groove in the front. So what I'm going to do now is just etch on a little mark and a little mark, 2 stripes, 2 stripes, to say that that one is going on that end, because at the moment I think that is the tension end, that when I get round to putting the holes in this thing, that's got to have six counter bores in there and springs in, and then that goes in there, presses against the bearing, and you can with it being obviously with it being an AC bearing, it allows you to take up some backlash. They say the sizes are all done to give you a certain torque on it. They tell you to drill the holes a little bit shallower. That's jobs for when I get on the milling machine. But I'm quite happy with that, onto the fact that nothing snapped. So I've got 2 more to do, and I'm going to do 2. I mean, it's going to be interesting. What I'm going to do off camera is take this one out later on, put it in there. Once I've clocked this up, and just clock this bore up and see where it is, and I'll get back to you later on. But I'm going to do the other 2 off camera, and then we'll get them all finished. Okay, these 2 are now done. Now I have put them back in, and they well, when I put them back in the first time, they look pretty good. I'm not putting them back in again, but you can see the pair of them have been done. I've not done that one yet. I'm keeping it as a spare. If anything goes wrong, there it is, and I can start all over again, so to speak. Yes, I did use this tool. You can see it's made by a manufacturer I'm not going to mention because they don't pay me. Not by this company that's made the older, different company. Let's shift them all out of the way. That has now got 1 hole to have in it, which it's just a drill hole, drilled and tapped. It's for filling oil up, putting some oil in when you're done.